Hello everyone, my name is Jalal Hamidash and my paper was about artificial intelligence planning, systems and techniques. Before we go ahead and dive into the presentation, I'd like to go ahead and cite its contents. We're going to start with a pretty small example of human planning, what human do as acting without planning or acting upon planning. What is planning versus artificial intelligence planning? We're going to give an example of a planning problem, which is going to be the Tower of Hanoi. After that, we're going to give a brief definitions of the planning domains, domain specific planning, and domain independence planning. We're going to also know why is domain independence planning is so important. And I'm going to explain how does planning work by giving examples that are going to be the forward chaining planning, which is going to be the depth first search algorithm, the breadth first search. We're going to know what heuristics are, and I'm going to explain actually the famous A-star algorithm. We're going to talk about admissible heuristics and briefly talk about heuristic computation, and then it will be the conclusion, and we'll open actually, I will finish my presentation and open it for questions and answers. So, first thing first, what is acting without planning when it comes actually to human planning? Humans tend actually not to plan for purpose that are immediate, like just grabbing objects, moving an objects from point A to point B. This is a task that doesn't really need a planning. When we are performing a well-trained behaviors, like if I work out every single day and I'm an athlete and I am fit, then for example running 3 miles for me doesn't, or like lifting for example a certain weight doesn't need any planning for me. But for someone who is debut, who's just starting actually that kind of sport, planning is required to know the technique, how to pick up the weights, not to hurt yourself, not to harm your body, and stuff of that nature. When a course of action can freely be adapted. Traveling, for example, I'm traveling from point A to point B, and I don't really need any planning because at any point I can go ahead and change my direction to a point C. So it is adaptable. Humans tend actually to plan. So we tend to plan for situation when we are addressing a new situation. This is something that we need to plan for. When tasks are pretty complex, any complex tasks, basically, we cannot do it just. We can just go ahead. We cannot just go ahead actually and start executing the tasks. It might need actually some planning before we start it, unless we are used actually to the complex tasks. But that falls actually on the category that we stated on when we talks about when human actually don't need any planning. When the environment imposes high risk or costs, although actually we are trained to do a behavior, when the outcome is risky or costly, we pay extra carefulness and we give extra attention actually to what we are attempting to do, and we plan for it to avoid any losses. When collaborating with others, and this is often actually happened inside the collaborative environments of companies, at work, or between students who are actually working on a group projects, they need to collaborate, so they plan actually how to do that tasks. So in general, we human only plan when it is strictly necessary. We do not plan for all our activities. So in basically in a planning problem, we have an initial state, and we have a goal state, and we have actions to take to get us actually from the initial state to the goal one. From this perspective, planning is an explicit deliberation process that chooses and organizes actions by anticipation to their outcomes. So, to clarify more, so we know what the initial state is, and we know actually what the goal state is, and we have to do a deliberation process to organize actually and choose our actions to get from the initial to the goal state. So an AI plan, artificial planning, is simply a computational study of this deliberation process. Um, we're gonna give an example basically to help our imagination basically absorb the meaning of a planet. So this is the Tower of Hanoi. Most of us probably are familiar with it. So it is a game basically, and the gamer or the player is supposed to move all the discs from one side of the tower to the other side. So defining the initial state will be all discs placed on the left stack of the puzzle or on the right stack of the puzzle. It doesn't really matter which side actually you start from. And the goal state is to move all the discs to the right stack of the puzzle or to the other side. Now, the planning that needs to be done will involve actually the actions, which is the actions will be you move actually only the top disk each time. You cannot move a disk that is not on the top, and no smaller disk should be in a below position. That is basically what needs planning. So planning in this case in this game will involve respecting actually those couple rows of the game. So planning domains. We have a domain specific planning. Domain specific planning is a representation and techniques that are adapted to each problem. For example, for path and motion planning, we can think about it as RoboMotion planning. Basically, we're trying to move a robot from point A to point B, so we have actually to give it a path to get to its destination. Perception planning, we use an algorithm basically that make the robot understand actually the environments where it is at, like just in case there are some moving objects that he needs actually to avoid or stuff of that nature. Also, there is manipulation planning and communication planning that fall under the domain-specific planning category. Domain-independent planning is a little bit different. While on the domain-specific planning, we use a different planning for each problem that we have. In the domain-independent planning, we use a generic representation and technique that solves actually all problems. It So it is one algorithm or one solution that gets used for different kind of problems. So the general understanding is the domain independent planning complements the domain specific planning. Why is the domain independence planning is so important? Because one solver can solve any problem. It saves money and time when it comes actually to investment companies and businesses, because they don't need to invest time and money to write a new solver. They use the same solver again and again to solve all kind of problems. It saves time in getting implementations up and running because we already have them, and it avoids basically redundancy, doing the work again and again. So how does planning work? We're gonna know how planning work through a couple examples actually of different solutions. The very first one will be forward chaining planning, and second one will be the heuristics. Forward chaining planning, the very first example we're given is the depth first search. Most of us are familiar actually with this. So if we are going from point A to point E, and we're using the depth first search method, we're going to generate the first child of the current node, which is A, and do the same actually for the first child. So from A to B, and B does not have any children, so from A to S, and then from S we're going to generate the first child of S, which is C, and then again the first child of C, which is D, and then a second child, which is E. And now we're going actually to backtrack the most recent node with an expanded children, so from E to C to S to A, and this way we would know the path actually from A to E through this depth first search methodology. The second example is kind of similar to depth first search, but it is the breadth one. In this situation, what we do is we generate all the children of the current node. A, we generate B and S, and we expand the node in the order that they were generated. So from A we generated B and S we generated C and G, and then so on and so forth until we get to our destination or to our goal. The next thing that we're gonna talk about how planning works is our heuristics. What's a heuristics? A heuristic is simply a function that takes a state and return an estimate of its distance from the goal. So whenever we have a problem, we have data about that problem. So we have to create a function that we feed actually a part of that data into that function, and that function gives us an estimate or an answer of how far are we are from the goal. Heuristics are only guidelines; they are not precise answers, just best guesses. In fact, if they were actually answers, there will not be a need to do a search because we would already know the answer. So a great explanation and implementation to heuristics would be through actually the A-star algorithm. The A-star algorithm actually is a pathfinding algorithm. It's one of the best and popular technique used in pathfinding and graph traversal, and it is widely used in RoboMotion planning, and it's in gaming like soccer, football gaming, and stuff of that nature. In A-star algorithm, the way heuristics are used is it picks the node according to a value f. That value's parameter is equal to the sum of two other parameters. Let's name them j and h. At each step, to find the path at each steps, it picks the node actually that is having actually the lowest f. F is G plus H. G is the movement or the cost to move from the starting point to a given square on the grid, following the path generated to get there. H is the estimated movement cost to move from that given square on the grid to the final destination. So this is an explanation of how the A-star algorithm works. In different problems, different kind of heuristics actually will be fed to other solutions or other algorithms. And from this point, we can understand that picking actually heuristics is very important to have actually the less costly answers, and those kind of heuristics are called admissible heuristics. Admissible heuristics actually they never overestimate the distance to the goal to give you a precise answer, and given an admissible heuristic to a star, we'll find an optimal solution which is the least costly. So we can go to from the goal, from the start point to the goal points through different paths. Let's assume actually that these two squares right here actually on the top don't exist. So, or like assuming actually taking actually the map the way it is, we could have gone actually two squares actually to the right and four squares down, and then all the way to the right actually to the goal to the goal or the destination. But that will be actually more costly than just going straight diagonally here, going down actually one square and going all the way actually to the goal. um, basically, we are using an admissible heuristic with A star to find the optimal solutions, which is actually the shortest path from the start point to the end point. Admissible heuristics could be used for to give an optimal planning. So basically, it aims to find the least costly solution. The question uh, is it possible to generate admissible heuristics? Well, a lot of research are taking place basically. That depends of the nature of the problem. Some problem are more complex than others, and they need actually more research to be able to generate admissible heuristics or close to, or could be actually the closest as you could to generate admissible ones. Because heuristic calculation is not an easy process. It's a very expensive process, and some planners are spend actually more time calculating heuristics than performing the search. There is a planner that is called first fast forward planner. It spends 80% of its time to just calculating the heuristics. And heuristics must be very informative and guiding to the planner to make calculating them worthwhile. If they are not informative, then spending a lot of time will be costly actually to the application or to the problem that we are solving, and the results or the solution is not going to be optimal. So in the end, I just would like to emphasize that AI planning is an explicit deliberation process that chooses and organizes actions by anticipating their outcome. It aims to find the least costly solution. It works in different search methodologies, where each is used to solve a certain nature of problems, and research on artificial intelligence planning are continuously taking place as they provide intelligent solutions to the business world. Thank you very much for your attention, and I open it now to questions and answers.